Okay, so in this video I want to give a brief overview of computer partitions. What are they, why we use them, that kind of stuff. So most computers use a hard drive like this, or it has a solid state drive. And with a hard drive, on the inside of it, you have a rotating platter, magnetic platter, with an arm that swings back and forth like this. And this platter, or this arm, is able to magnetically change the information on this disk as it spins around. With a solid state drive, the entire thing is like a giant flash drive. So it removes all the mechanical components of a normal spinning hard disk like this. So it's able to operate a lot quicker because there's no mechanical parts that need to move or synchronize or anything like that. And it's able to run very quietly. There's no moving parts. So it's also a lot less susceptible to shock like these are. But your computer needs a way to be able to talk to both of these, and the way that they talk to them are basically exactly the same. Even though your solid state drive or your hard drive has a rotating platter and it's divided up into sectors and tracks, your computer doesn't see it that way. Your computer will see it, whether it's a spinning hard drive or a solid state drive, as a single continuous block of memory. So I'll just call this hard drive, or just space, memory space. So here, take your hard drive platter here, for example. All of the tracks and the sectors and all that are on the disk itself are basically ignored by the computer. On this back of this board here, you can't see it on this side, but there's a controller inside of here that manages where the arm is and how it keeps track of where data is stored, and what it's able to translate a request from the computer into something that it's able to look up where that information is stored on this drive. With a flash drive, it works differently because, again, there's no moving parts, but it still needs, there are some disadvantages to flash. For example, there is a write limit on flash, so a flash cell can only be written to a certain number of times before it goes read-only. So to get around that, the controller will do something called wear leveling, where it will automatically move data around on the drive. So if there's one spot on the disk that's being written to a lot, it'll move that spot around or spread it out over the entire disk, so, or over the entire drive, so that that one area doesn't get worn out too fast. But again, the computer doesn't really care about that. All the computer sees really is just a single continuous block of memory, starting from address 0, going up to however big that drive may be, which could be gigabytes, it could be terabytes, it could also be a very small chip. It could be, 32 kilobytes. But regardless of its size, the computer will see it the same way. So to effectively manage it, though, there are a couple things that need to be done, or the computer does, to keep track of what data is on the disk and how to divide it properly. So if you install Linux, for example, most of the time what Linux will do is it will take this entire drive space and it will start dividing it up into certain blocks. A very simple installation may have just 2 partitions, for example, or 3 partitions. And what a partition is just a logical block of code, or logical block of memory that's been separated. So in terms of your hard drive, it's exactly the same. It has no concept of partitions or file systems. The drive itself is just a drive. It doesn't recognize this. This is entirely within the computer. And what it will do at this point is it might say, okay, this part right here is the root partition. And we got a different color for this. This partition here might be for like home. So all of your home information for your user account would be on here, but the operating system for Linux or whatever would be stored in this root partition. Now this is entirely arbitrary. There is no real set in stone principle behind partitions. Partitions can be almost any size and can be used for all sorts of different purposes. So you saw for installing an operating system how it created several partitions. Windows creates a few more than that, but let's say this is not your primary hard disk. Your primary hard disk is going to be the one that the computer is going to boot off of. So it's going to be the one that contains Windows or Mac or Linux, all the system files for that. That's where the computer is going to look to boot that data. Let's say you have a second hard drive. So instead of this being the main hard drive, let's say this is just hard drive 2. Under Windows, it might be like drive E or F. Whereas your primary drive would be drive C. And again, that's a legacy reason. There's other drive letters that are more commonly used for certain things, like drive D is for CD drives and drive A is for floppy drives. Anyway, this is a non-primary disk. So what we could do is we could have this set up in the system with a single partition that covers the entire memory space, and plug that directly into the computer, install a file system on top of it, and in your computer it will just show up as a single drive, and we can just say this is drive F. So this entire block of memory here is now considered to be drive F on the computer. But that's arbitrary. Again, we could make it so that it has two partitions. So I could say that I have two partitions here. So I have partition 1, partition 2. And first partition gets mapped to drive F. Second partition gets mapped to drive G. So your hard drive hasn't changed. The data on it hasn't. There's no physical or even a conceptual split in this drive. All of this is taking place within the operating system itself. So to your hard drive, it's still a single drive, but to your operating system, like Windows, for example, it now sees these two partitions as two different logical drives that are completely separate from each other. They may as well be different hard drives, even though they both lead back to the same drive. And that might seem kind of weird, like why would you want to do that? Well, again, in the beginning, if we were installing an operating system, it would do this to store different types of files, different areas would store different, would be used for different purposes. If you wanted to, you could set it up so that this could be a user partition, and this could be a backup partition. And in terms of the computer, that's perfectly valid. It will see these two partitions as separate entities. Now, one common use for these types of partitions is, again, for a system partition. So I'm going to flip this up to its side. So let's say this is our memory block here. So this is the entire span of our drive here. All the memory contents, if we laid it out flat, would be like this. So one aspect of partitions that's pretty important is, for example, let's say I have two different partitions here. In fact, this partition can go for the entire rest of the drive. So this is one partition here, and this is one partition here. And one important aspect of partitions is that they are completely removed from file systems. So what you could do is you could have one type of file system here, let's just say it's FAT file system, and your second partition could be NTFS. That's perfectly valid. The reasons you might want to do that is, well, your computer, for example, if it's an older computer or a certain type of computer, it may not be able to recognize certain partition or certain file systems. Because the way file systems work is you have your physical memory here And on top of that, you have your partitions. So partitions, let's put P for partitions, partition 1, partition 2, and on top of that, you have your file systems. And then you have all your files and your folders stemming up from that. So you can see how you have your physical block of memory, which is, in this case, it's a logical block of memory that the computer sees, but it's just for the sake of argument, call it physical. Writing on top of that, you have your partitions, and then on top of that, you have your file systems. Now, what you could do is you could ignore the partitions altogether, theoretically, and just put a file system directly onto the physical partition, or onto the physical drive itself, not having any partition at all. Not always a good idea, but it's theoretically possible. It's not very common. Certain types of memory may not require a partition. If it's a small block of memory and you just want to store some files onto it for an embedded system like that, it may not even need partitions at all. It may not even need a file system at that point, but that's kind of getting out of scope. But this is generally how it looks when you go to when you break down the concept of partitions and file systems. So sort of going back to this example of why you would have two different partitions with two different file systems, you kind of need to go back in time a little bit to see how this came about and why it was done this way. So when your computer first starts up, for example, let's just say it's a computer, the first thing it's going to do is it's going to load some of its internal memory. And this internal memory is called the Basic Input-Output System, or BIOS. Nowadays it's UEFI, but let's just, for simplicity's sake, just refer to it as a BIOS. This BIOS is not part of the hard drive. This BIOS is actually built into the motherboard of the computer. And this BIOS gives the machine enough information to start loading other information. So it will initialize things like the main processor and some of the memory addresses. It will initialize the keyboard and the screen, like the monitor, and it will load drivers to allow it to read from a hard drive like this. It'll tell the machine how it's able to access this device here. But the BIOS is generally a very limited system. It's really only there for configuring very low-level operating system or computer options, like what drive to boot off of, some power options maybe. So this, as an effect, this is a very, very small amount of memory that it's working with. And the NTFS file system, for example, it could be other ones like ext4. The point's kind of generally the same. The NTFS file system is pretty complicated, and to allow a computer to understand it, it requires a pretty substantial amount of code. Whereas the FAT file system, whether that's FAT16 or whatever happens to be that particular version of FAT, is a very simple file system. So to instruct the computer on how to read it requires a very, very small amount of memory. Small enough that it can fit inside of your BIOS chip. So your BIOS is going to load into your computer all of the information it needs to be able to access this FAT partition. And inside of this FAT partition contains more information, including information on how to access NTFS. So once it loads from the BIOS, it will go to drive. In this case, it's this drive here, and it will look for a predetermined area to boot off of. In this case, it's the FAT partition. And from there, it's able to start loading basic subroutines and drivers, and one of them includes the driver to read NTFS. And that's generally when, in this example, it's for Windows, so this would be like Windows is first starting up, it's loading all of its very basic initialization stuff, and eventually loads the driver in order to store this, or in order to access this.
So now that we've talked about what partitions are and how they're used and why they exist to begin with, Let's go ahead and make one and get a file system on it and let Windows recognize it. If you're on your personal computer, may not be a great idea to do this because it can affect your system in ways that are not necessarily hard to reverse, but can be just a little confusing if you're not used to dealing with partitions. If you're in the BMET lab, specifically BMET 121, you can edit the partitions on those computers all day long. It's not going to hurt them. Those computers are set up so that as soon as they're restarted, all the changes you've done are erased. So it doesn't matter what you do to it, you can completely break Windows if you want to. You just restart the computer and it'll come right back up like nothing happened. They're in a permanent state of like Groundhog's Day. But so let's just assume you're at the BMET computers, or you have a virtual machine like I do, which you can mess with and not have to worry about. What you want to do is go down to the Start menu here, right-click on it, and then go up to Disk Management. This will come up with a window showing the actual physical drives on the machine. So up here you can see I have a list of partitions, not necessarily drives, partitions. And this window down here, this actually will show you the physical drives. So I have disk 0, which is the actual physical drive. And on disk 0 I have two partitions. One is for system reserved and the other is for the C drive. And if I go to my File Explorer, open that up, and go to this PC, I can see here under Devices and Drives, there's the C drive. So that's the same as this right here. This system reserved partition is part of Windows. It's a protected partition that contains a lot of underlying system stuff for Windows that needs to be able to operate properly. It's best just to leave it alone. We don't need to worry about it right now. But you can see even on this disk 0, there are two partitions on this Windows installation, which is right out of the box. There's no modifications done to it. If you installed Windows, this is how it would look. So what I'm going to do is I'm actually going to take my C partition and I'm going to shrink the volume. So you click on the C partition, right click on it, and go down to shrink volume. It's going to see how much it can take off. That's an aspect of the file system of NTFS. It gets very technical, but there is a limit to how small you can make it based on certain factors, but let's not get into that. I'm going to say I want to reduce the size by 10,000 megabytes or 10 gigabytes. And that will take it away from the C partition and make it into unallocated space, which is not being used. So I'll click shrink, and that'll take a minute or a second, and that comes right up. And you can see I have my system reserved, I have my C partition, which is now smaller, and I have almost 10 gigabytes of unallocated, unused memory on that drive. If I go back to my C drive, or my File Explorer here, you can see the C drive still has 31 gigs, but if I refresh this, it's gone down to 21.7 gigs. So the C drive, quote unquote, has just gotten smaller. In reality, that's not actually a drive, it's a partition. So now let's take this unallocated space and put it back to work. So I'm going to click on the unallocated space, right click on it, and then click New Simple Volume. And that will bring up this little window here where I can click Next. It'll ask how much of this do you want to use, and it defaults to everything, and that's fine. Unless you want to make more than one partition, you can just leave this as it is. Click Next. It'll ask you what drive letter you want to assign to it, and you can basically pick any of these. Some of them well, they used to be reserved. They're sort of in a nebulous state. A and B generally are ones you don't want to use, but anything after that is fine. So I'm just going to pick F. And I click Next. And at this part, it'll ask you to format, and what that basically means is it's going to put a file system into that partition. So it's going to partition it and then put a file system on it. And we could skip that. We could say, I don't want a file system, just leave it as a partition, blank, nothing else on it. And then you could put a file system on it later but I'm going to go ahead and put a file system on it so it'll just show up as a normal drive. So I'm going to call this backup. And we'll probably want to make sure we click or have this quick format checkbox selected, otherwise it'll probably take a while. I'm going to stick with NTFS. You can see FAT32 or FAT32 is the other file system type that Windows supports. Allocation unit size, that's something we don't need to worry about right now. That's a whole different topic. Just click next, and then click finish. And you can see now you can see it, Windows almost immediately recognized it and said, it detected it as a removable drive, even though it's not a drive and it's not removable. It's actually a partition on the main system drive, but as far as Windows is concerned, it doesn't see it that way. So now I have my system reserved, my C partition, and my F partition. And if I go back to my Explorer here, you can see I have the C drive, I have my CD-ROM drive, which is, we can ignore that, and then I have my brand new F drive for backup. And in here is just blank. You can put something in there if you want. I'm going to put a folder, and in here in that folder I'll put a text file, whatever. But the point is that Windows sees the C and F drive as drives. It sees them as actual separate entities, even though they're really not. They're really the same. It's dividing up the same drive to act like multiple virtual drives. And to reverse this process, what we can do is we can go to our disk management utility here, right click on our new partition we made, and click delete volume. Now this will delete everything in this partition. So if you put anything in here that you want to keep, make sure you back it up or move it somewhere else, because as soon as we click delete volume, it's going to erase it. So click OK, click yes, and you can see it's gone back to unallocated. And if I go back to my File Explorer, that drive is now gone. And now, since it's just unallocated, we can just tack it back onto the C partition here. So I'll go back to this, right click on it, extend volume. It'll bring up a similar window like this. Next, and just click next again, and finish. And there you go. It's taken that unallocated space and put it back onto the C drive. So hopefully that clears up a little bit about partitions, why they're used, what they do, and that kind of stuff. Again, some of this stuff is sort of a history lesson in computers, because some of the reasons why things the way they are decisions that were made 20, 30 years ago and just sort of have persisted on to today. But if you need to do a partition in Windows or some other system, hopefully this will help you understand how that works and what it's for.